Question number 83. A capacitor of capacitance C is given a charge Q at t equal to 0. It is connected to an ideal battery of EMF epsilon through a resistance R. Find the charge on the capacitor at time t. So this is capacitor. Say we give name as A, and then there is another capacitor. We give its name as B. And there is the resistance. Now, here charge on capacitor A is given as Q. When it is connected, so it will start discharging and this capacitor will get charged. So at any time t, suppose charge Q flows through this wire and this capacitor acquires charge small q, then remaining charge capital Q minus Q will be left on this. So at time small t, charge on capacitor A is Q minus Q. So let's write the potential VA. So charge Q minus small q divided by C. And since this acquires charge small q, so potential on it will be small q upon C. Now we find potential difference. So VA minus VB. So it will become Q minus 2 small q divided by C. If we find current, so I will be Q minus 2Q divided by CR. And I is also equal to dQ by dt. So we write dQ divided by Q minus 2Q equal to dt divided by RC. We integrate it within limits 0 to small q and 0 to t. So this will give minus 1 by 2 integration dt upon t, or here we put q minus 2q equal to t, then minus 2 dq equal to dt, or dq equal to minus half dt. And if we put the limits, so when q equal to 0, so this will become capital Q. And when q equal to small q, then limit will remain q minus 2q. And this will become dt upon t equal to integration 0 to t dt. But here, since dt is in RHS, so let's write some other things. Suppose we write it u. So this will be du. So value of du. So this will be du upon u. And this is dt upon RC. Now this will become log u. So minus half log u base e limits q to q minus 2q equal to, this will become t upon RC. We can shift minus sign to RHS. Minus sign plus and this 2 also. So this will become log base e q minus 2q divided by, it will be minus, then property of log m minus log m upon m. So this will become capital Q equal to minus 2t upon RC. If we remove log, so we will get q minus 2q divided by capital Q equal to e to the power minus 2t upon RC. Now we divide each term by q. So it will become 1 minus 2 small q divided by capital Q equal to e to the power minus 2t upon RC. our concern is to get value of small q. For that purpose, we shift this e to the power minus 2t upon RC to LHS. So 1 minus e to the power minus 2t upon RC equals 2q upon capital Q. And finally, we get small q equal to capital Q by 2, 1 minus e to the power minus 2t upon RC. So this is answer to question number 83. Now let's go to question number 84. A capacitor of capacitance C is given a charge Q. At time t equal to 0, it is connected to a battery of EMF E through a resistance R. Find the charge on the capacitor at time t. This question can be solved in two ways. The shortcut is there that the charge given Q is getting discharged. So the equation for this will be Q equal to Q0 e to the power minus t upon RC. Here Q0 means capital Q. Capital Q is Q0. And due to this battery, this capacitance will get charged. And charge anytime will be, here maximum charge will be equal to CE times case of charging. It will be 1 minus e to the power minus t upon RC. And that will be our answer. So this is one method. Now let's consider another method. So here EMF of the battery will be equal to, suppose current I flows through this wire, then IR plus potential difference across capacitance. So we write the equation as Q upon C plus I times R equal to EMF, or Q upon C plus, in place of I, we can write dQ upon dt times R equal to E. We can set this Q upon C to RHS. So dQ upon dt will be E minus Q upon C divided by or dQ upon E minus Q upon C equal to dt upon R. We can integrate it. So integrating within limits, initial charge is capital Q, and suppose final charge becomes small q, then this will become dQ upon E minus Q upon C equal to integration 0 to t from dt upon R. So this will give minus C times log of E minus Q upon C, limits Q to small q equal to t upon R. Now, further, we put the limits. So, on putting the limits, it will become, let's remove this portion. So, this will become log of E minus Q upon C divided by E minus capital Q upon C equal to minus t upon RC. This is log base E, so we can remove log. So E minus Q upon C divided by E minus capital Q upon C equal to e to the power minus t upon RC. Now further, so we write it E minus Q upon C equal to E minus capital Q upon C times e to the power minus t upon RC. So E minus E times e to the power minus t upon RC equal to E into e to the power minus t upon, sorry, here this q by c term will go to RHS q by c, and we will get here capital Q upon C e to the power minus t upon RC. We can multiply by C, and C can be taken common. 1 minus e to the power minus t upon RC equals, here it will become Q minus capital Q e to the power minus t upon RC. Our concern is to get small q. So small q equal to capital Q times e to the power minus t upon RC plus CE times 1 minus e to the power minus t upon RC. So this is case of discharging and this is case of charging. So answer is same, although this method is little complicated. Thank you for watching.